Hello everyone, and welcome to the Knowledge Discovery and Data Mining short course presented by Charles Sturt University. My name is Guy Coward and I'll be your MC. Before we begin, a little bit of housekeeping. All webinars for this course will be held at 7:30 p.m. Australian Eastern Daylight Savings Time, with recordings made for those who cannot attend. Despite the recordings, if you can make it, we hope you'll attend the live webinars and contribute to a collaborative learning environment. One of the great advantages of joining live is the ability to ask questions of the course developers and chat with other attendees during the webinar. We ask that you direct all questions relevant to course content to the Q&A section, and that you send all administration type questions, dates and times and resource availability to the support team in chat. And you can look at the icons at the bottom of your Zoom window to choose. As I said, you can chat with your fellow students as well, and you can make that choice by toggling through the drop box once you open the chat log and setting your chat to all panelists and attendees. There are usually some very experienced attendees who can augment the lecture as we go along with their personal stories. We'll have Q&A sessions periodically throughout the course, but if a question is particularly relevant, I'll interrupt during the lecture. For those who've never taken part in a short course with us, IT Masters is a training organisation that exists as partner to Charles Sturt University. Charles Sturt is providing this short course to showcase the graduate certificate in applied data science. But with that said, we hope this course stands alone in its own right and is its own reward. We want you to learn some useful information, have some fun, and hopefully make connections with some of your fellow students. To date, over 2,000 people have enrolled in this short course, so you're spoiled for choice as to who to talk to. Leif is here in an administrative and technical support role for IT Masters, and he's also responsible for the course page, or the Moodle page, which is where you'll find the other materials needed for this course, links to study guides and readings and discussion forums, and any exercises. If you have any questions, please feel free to contact us using the details on that page. We'll begin tonight with Dr. Jason Howarth, who will provide a little context to this short course by detailing the grad set it was built out of. Jason is helping to drive the transformation of online education at Charles Sturt, which is appropriate given he completed a PhD on MOOCs. He's been a great friend of IT Masters short course program for many years now, so hello Jason, and thanks for coming. I'll introduce the short course co-developer Zahid Islam after this presentation.
Thanks so much, Guy. Appreciate that. Can everyone hear me just quickly? Is my voice coming through? Great.
Yep.
So thanks, Guy, for the wonderful introduction. Welcome everyone to our short course tonight. I will be brief with my introduction to the overarching program where this short course comes from at Charles Sturt University. I just want to spend 5 minutes talking about the graduate certificate in applied data science, which is offered as a new course from next year at Charles Sturt University, and just briefly explain how the short course that you're doing tonight fits in with this overarching program. I will, at the end of the short course series, for those who are interested, come on as the very last speaker to tell you more about the program, and if you do want to learn more about how to enroll, I can give that information to you then. Some really quick overview information on Charles Sturt University. We're a regional Australian accredited university with campuses all over New South Wales, particularly in regional areas, but predominantly Charles Sturt is an online teaching university. So we have around about 44,000 students, but our online cohort totals 25,000. So most of our students are online, which makes us a great university for people who are working, who have families and other commitments. So many of our students do study online and part-time. One of the courses that we're offering, and which obviously relates to the short course in data mining presented by Zahid commencing tonight, is our new graduate certificate in applied data science. So this course kicks off next year. It's a 4-subject course, only 4 subjects to get the award. It is a postgraduate level program, and you can see briefly there that it has 1 core subject, Foundations of Big Data Analytics, which is all about the practical concepts behind big data. And then you get to choose 3 electives. One of those electives, ITC 573, Data and Knowledge Engineering, is related to the short course you're studying tonight. It's not the full subject, obviously. We're sort of sampling concepts from the full subject, the first few topics, giving an overview of that material, hopefully whetting your interest and potentially coming on if you like the idea of studying a graduate certificate with CSU or Charles Sturt. So if you're wondering what a graduate certificate is and where it fits into the overall academic hierarchy, it's a postgraduate award, which means it's higher than undergraduate, and it's just below a master's. And it's certainly easy to complete a graduate certificate and then to move into the master's and potentially get credit for the units that you've done. So another quick point to mention is you don't necessarily need an undergraduate degree to get into the graduate certificate. So if you have industry experience, it could be in different areas. Let us know if you are keen to study the graduate certificate, because very possibly there is an entrance pathway for you. All of our subjects in the course delivered online, so you don't need to set foot on campus. It's all delivered through our learning management system. Everything is transacted online. There's no disadvantage there. As I said, we don't even have on-campus students for this particular program, and you'll be studying with like-minded people and able to do it part-time and in a way that allows you to work around your professional and personal life. So with that, I will finish up. I don't want to spend too long tonight detracting from Zahid's presentation. If you do have any questions that you would like to ask either Sabi Riemann, who is the course director for this program, his email address is there on screen. You can also email me, always happy to hear from potential students. If you have any questions whatsoever about the program or about Charles Sturt. And as I said, at the very end of the lecture series, in a few weeks from now, I will come back, give a bit more detail about the program for those of you who might be interested in enrolling. So enjoy your short course, and I will hand back to Guy and Zahid.
Thank you very much, Jason. While you're here, Jason, just one quick question from that. Will there be a master's in data science offered?
At the moment, it's not there. We're keen to test the waters in terms of how popular the graduate certificate is. I suspect very likely we will additionally have a master's. It's going to depend on the demand for this course. But given the demand in industry for people able to manipulate and make sense of huge amounts of data, I suspect the master's is not too far away.
Fantastic, thank you. Alrighty, Associate Professor Zahid Islam has been waiting very patiently and is Director of the Data Science Research Unit at Charles Sturt University. He's published 100 peer-reviewed papers, and I can't think of anyone more qualified to start this short course off, given Zahid was chair of the 16th Australasian Data Mining Conference last year. Could you please join me in thanking Associate Professor Zahid Islam for running this short course in the chat box. Hello, Zahid.
Hello, Guy, can you hear me now? Sorry, I did not.
Yep, absolutely.
Yeah, I was trying to figure out how to unmute.
We've got you now.
Yep, thank you very much. And thanks, Dr. Jason Howard, for a nice introduction to the overall course. And Guy, Mr. Guy Coward, thank you very much for introducing us. And thanks to everyone who are participating. I know your time is very valuable. I hope you will be enjoying this short course. We will try to introduce some basic ideas of knowledge discovery and data mining. And I will also try to show you some software tools and techniques, how to do some real life data mining on some data sets through this short course. And in this subject, actually, when you if someone studies the subject, the full subject, then there will be some theoretical understanding as well, theoretical part as well, so that you just do not know how to do things, you also know why things are working this way, something like that. So let us start this short course. My name is Zahid Islam, and I will be presenting the first 2 weeks of the lectures for this MOOC, and then my colleague, my wonderful colleague, Dr. Michael Byong, will deliver the last 2 lectures for this MOOC. He is a wonderful data miner. Okay, so now the next slide is about myself. So as you know, my name is Zahid Islam, and my area of interest, research area, is data mining. I work on various types of data mining, various tasks of data mining, knowledge discovery, classification. We develop our algorithms. Generally data miners can be classified in 2 different groups. I have my experience. One group is applied data miners, like they generally work on problems and they apply existing data mining techniques, whatever technique that be, to solve that problem. Right, so that is a very valuable type of research. Whereas another group, and I possibly fall slightly on this second group, also develop own data mining algorithms. So to solve some data mining problems, and then they can apply those algorithms. So I possibly fall in that group. We develop, say, classification algorithms, and we possibly identify some challenging cases, for example, data sets with some challenging properties, and then how do we actually develop new algorithms to handle those kind of situations, that sort of thing. Anyway, so I will introduce the data science, what is data science, what is data mining, etc. today, and in a minute. And yeah, we have a nice data science research unit here, which is a faculty level center at the moment, and I'm the director of that center. We have many colleagues here in data science. We do practical work. Yeah, you can actually learn a little bit more about me from this web link. And I have a YouTube channel as well. You can find quite some YouTube videos on various data mining tools and techniques and ideas and discussions. So feel free to jump in and watch them at your free time if you like. Now, my other colleague that will present the last 2 lectures is Dr. Michael Byong, a wonderful data miner. His PhD was in privacy preserving data mining, on privacy side of the data mining, as far as I remember. And this is his webpage, and you can actually see his details there as well. Michael will introduce himself when he comes on the 3rd lecture. Now, as I said before, the structure of this lecture today will be, first I will discuss what is data mining, what is data science, why it is important, and some basic concept, very basic concept about this data mining. And then we will show some real data mining actions, okay, how to do this, that sort of thing. The introduction of the data mining will also talk about the data lifecycle. You know that there is a life cycle for data science, and this can be one way to explain the life cycle. It may start with data collection. So first you need to collect data, and generally people collect data through various different ways. For example, you can actually run a survey, and survey participants may provide their information through survey, and that way you can collect data. Sometimes people may collect data through sensors, say weather stations on farms. So these weather stations may send various weather-related information like temperature, humidity, precipitation, net radiation, etc. So those kind of things can be collected on farm and sent to the central server. People may collect data through that way, or you may actually collect data through wearable sensors and so on and so forth. So that's data collection. Once the data are collected, first thing, the second task will be data pre-processing and cleansing. right? So here, generally, your data may be signals, time series signals, or your data can be images. So you need to convert the data into a two-dimensional table sort of thing for data mining techniques to work generally. And that's one task of the pre-processing. So that sort of pre-processing thing you need to do. Sometime your data can be time series data, and then you generally data scientists will convert time series data into a kind of a non-time series two-dimensional table by capturing information, time series information in a smart way. So that is also part of data pre-processing. Sometimes your data set, when you collected the data, could have missing values. Some values can go missing. Say, for example, you are asking few questions through a survey, and a survey participant simply did not answer one of those questions or some of those questions. So those value will go missing, right? Or let's give you another example. If you are collecting data through sensors, say weather stations, and your sensors may go may have a flat battery for some reason, and it did not collect data for some time. So for whatever reason, you may have some values missing. So that those missing value may need to be imputed for better data mining accuracy, etc. The main purpose of data mining is to capture the overall knowledge from a data set, the making sense of a data set, so that you can learn about the data set and then possibly use it for future prediction, for strategic decision making, for business enhancement, business profit, etc., or better service providing better service. So these are the reasons possibly. And then your data set can also have corrupt values. Some values can be incorrect, right? So then is there any way you can detect those incorrect values automatically? Say, for example, someone was asked to to enter their weight, body weight, and the expectation was in kilogram. Maybe he provides the information in pounds, say 120 pounds, whereas the expectation was in kilograms. Or somebody may say he's 1.6 tall in meter, 1.6 meter, but the question was in feet. So that sort of thing. So if your data may have incorrect values due to various reasons, and those incorrect values may disturb your knowledge discovery and overall pattern discovery, etc. So you may sometime need to rectify those incorrect values. So these things generally are considered as data pre-processing. So after you do the data pre-processing, your data set is generally ready, clean. Data pre-processing is also called data cleansing. And then after data pre-processing and cleansing, your data set generally gets ready for data analysis. And in this step, you may apply various data mining techniques for data analysis, like traditional statistical approaches can also be used along with. Look, this data science is also a kind of a creative area where some people, many professors I have seen, they discuss in a funny way that is it data science or data arts, because you need to be really very creative while discovering knowledge. There is no one single kind of way of doing it. For example, you can apply a decision tree algorithm on a data set to discover the first set of knowledge from it, and then from each of the path of the decision tree, you may explore further. You may make some queries, and to discover knowledge, you can do some clustering along with the decision tree, etc. So we will discuss those things in this short course one by one, slowly, and these things will make better sense slowly. But at the moment, I think all we are trying to discuss here is that the first step is data collection, then we do data pre-processing, and after data pre-processing, the data set is ready for analysis, and after we do the analysis, we generally discover some knowledge from the data set, right? So we generally want to see what it means actually. And then after knowledge is being discovered, then this is published, knowledge is conveyed, the message is conveyed. We get to remember here that, look, we are data scientists, but often our managers, our end users may not be data scientists. So we need to speak in their language, okay? So if for example, if we build a decision support system, then the decision support system should display the information in a user-friendly way so that they understand what we mean. And then after that knowledge is discovered, knowledge is published, our knowledge may reintegrated. So we learn few new things, and that may require us to collect more data, something like that. So this is the life cycle. Now, why is data mining so important? Maybe I'm sure many of you already work in data mining. Many of you are maybe very experienced in data mining. I have no doubt about that, but some of you are possibly more focused on a different area and maybe exploring what this data science actually does. So for a discussion purpose, like what is the usefulness of data mining? Look, data mining is being used everywhere these days. So almost every sector of life these days collect data, right? So imagine any organization will be collecting data mostly, almost. And then what is the purpose of the collection of the data if they don't analyze it, if they don't use that data for their business improvement and profit improvement or etc. So here I will give a few example only of some of the industry projects that we have done so far. I thought this could be one very nice way to explain the importance or usefulness of data mining. That I thought, like, through practical example, maybe I can convey that message very clearly. Okay, so I will be very brief. Say one of the project, the first one is health monitoring system. This project was funded by New South Wales Health, Marambiji Local Health District. And in this project, we developed a system that collects the data from all the hospitals and etc. And then we applied our own data mining techniques. Our own means CSU developed data mining algorithms to discover knowledge from the collected data, and all these things are happening automatically in the back end, in the background, and then it discovers the knowledge from the collected data, and that knowledge is actually converted in a very user-friendly way through graphs, figures, and if-else rules, something like that, so that clinicians, nurses, doctors, and hospital managers, they can understand the information, and so that they can intervene or they can take action to improve the hospital service quality, etc. Something like that. So that's sort of example. That's an example of why data mining can be useful. And I'm very happy to share with you that that project, after we finished it, actually received an innovation award from the Agency for Clinical Innovation in 2017. So you can see the value of data mining in health management. Now, the second example here is Coleambly irrigation system. This was an industry-funded project as well, funded by Coleambly irrigation area, where again we developed a system that collected data from the farms. So in Coleambly irrigation area, there were around 500 farms from my memory, if I can remember it correctly. And those farms, our system was developed in order to predict the irrigation water demand for next 7 days for every individual farm. So the farmers could order water, and then they used to have a SCADA system, and the irrigation company used to release the water for that farm. But sometimes it could take up to 7 days to reach the water after a farmer ordered the water. So as a result, they needed some sort of prediction system. So they needed to know in advance how much water they will need to irrigate after 7 days or so, something like that. So that system was done for that purpose. Can we predict water demand for every individual farm? We considered the farm soil type, farm crop type, cropping stage, average temperature, minimum temperature, maximum temperature, weather, etc. So that system was also very useful. we have a couple of publications there. You can find my papers on my webpage, and for most of my papers, the preprint versions are available, freely downloadable. Feel free to have a look if you want. Then the third one, look, the reason I'm discussing these industry projects, just to possibly share with you that data mining can help in many different areas, right? The first one was health, second one was irrigation, the third one was funded by Department of Social Services, and this was in partnership with Live Better CSU team, where I was one of the team member as well for all of these projects. And the project was around $650,000 project. What we did from data science, the project was multidisciplinary in this case. What we did from the data science point of view is we collected information about the seniors, elderly people in regional Australia, in our study area. And then we tried to find out the reasons for their well-being, for their aging, how we can improve their well-being, how we can improve their social life, etc. And then we discovered many interesting patterns, interesting knowledge that we suggested the Department of Social Services through Live Better and Live Better as well, so that they can intervene the senior people in the region to improve their life quality. And I'm again very happy to share with you that this project was then assessed by Deloitte, by the Department of Social Services. They engaged Deloitte to assess the project, and it received an outstanding feedback from the assessment team. Then the fourth one was Hobart District Nursing System. So this was funded by the Hobart District Nursing District. And here we tried to see the caregivers' quality of service, and can we improve it? So we came up with some ideas. It was again a multidisciplinary project, but data science part of the project was to assess the impact or the usefulness of the intervention plan, and in terms of the improvement of service quality, something like that. And the fifth one, I guess the last one here in this example list, is Sunrise and AgriFutures funded project. So through Food Agility CRC, here we are trying to understand the reasons of whole grain yield. So rice grain, when they produce rice grains, some of the rice grains can get broken. So broken rice grains, if a farmer actually produces lots of broken rice grain, so then he actually does not get good price for his rice. Okay, so in this project we are trying, this is a current project, we are trying to understand the reasons, influencing factors. Okay, it could be weather factors, it could be farming practice, it could be rice trade, so what sort of rice, it could be soil type, it could be what are the other reasons that influence, it could be milling process at the end, what are the things that actually increase the rice breakage or can decrease the or increase the whole grain yield. So, and if we can learn that, then possibly we can share that with the farmers for a future farming year, and we can suggest them to do things slightly differently, right? So that they can improve, they can increase their whole grain yield possibilities. So we can actually guide them as well. Given a particular season, we cannot control temperature, we cannot control maybe rainfall, but we can possibly control farming practices, or we can also, at the very least, we can predict how much whole grain yield they can expect, so that they can make more informed decision. So you can see that data mining can be used in wide variety of areas, and there are lots of other stories I can share with you. I'm mindful of the time, but but just to let you know that, for example, Walmart in the United States, Walmart has shops in, maybe it's a supermarket chain. It has in 9 different countries. They have their existence in 9 different countries, over maybe 3,000 shops. So they collect each and every transaction of sales transaction, and they mine those data. So it's very well known that everybody uses the data, collects the data, and analyzes the data these days. It's very useful.
Perhaps, Zahid, we could collect one more set just before we go to the next slide.
Mm-hmm.
We were talking earlier about finding out what your level of experience is. Always interesting to find out about the students. So I'll launch a poll now.
Yep.
What is your level of experience using data mining, machine learning, AI, and knowledge discovery? And if you'd like to talk, Zahid, about how that fits in your little flowchart there, that'd be really interesting. This is pretty simple data collection.
That's right. It's very simple but very effective data collection, Guy. So this is possibly what Guy is doing is another kind of a quick lesson for us, that for data collection, data mining, knowledge discovery, my personal experience is all we need to be sensible, we need to be smart. It doesn't always need to be complicated. It's nothing to make it unnecessarily complicated if simple things work. For example, here I can get a very good understanding of the cohort here, of the audience here, and I'm very happy to see that the enthusiasm of the participants. Yeah, so a lot of the participants have less than 1 year data science related thing, and some of them have more than 5 years even. So quite experienced data scientists.
Just go through that now. We had about 75% of people respond, of which 72 brand new or still learning or less than 1 year. 24% 1 to 3 years, so a good level of experience.
Very good.
And then about 5%, 4%, I should say, 3 to 5 years, and 1% more than 5. So that's an example of some data collection right there, and hopefully we'll feed that into integrating the knowledge and maybe changing what we do with the course.
That's right. This is very useful. Thank you, Guy. So shall I move to the next slide now?
Yeah, sure. Go ahead.
Okay. Okay. So I was then. So now let's discuss what a data set is. So this is, whenever we write papers, etc., this is one question that I have seen that people get generally confused, because in data mining, generally data set means a two-dimensional table like this, right? Here, rows are individuals or records, and columns are the attributes or features, something like that. You can consider the first row is the first individual, where columns are age, sex, so information about that individual. And one of these features or attributes can be the target attribute, like what is the diagnosis. So we are assuming that this is possibly information about some patients and their occupation, their life pattern, exercise, how many hours, they're smoker or not smoker, they drink or not, etc., how much they drink, and finally they have a particular disease or not. This is just a toy example. Don't worry too much. Maybe this does not make sense or make sense, but generally data sets will look like this, a two-dimensional table, and then you can apply data mining techniques on it. But the source of this two-dimensional table sometimes can be signals like this, okay? So for example, you can have EEG signal from a patient's brain, and the signal may look like this. Or the source of the data set could be images, like you have the image of Michael Byong and Zahid Islam, and you can actually have lots of images of Zahid and Michael, and then maybe you want to develop a technique that can identify Zahid and Michael from then on. This is just a toy example. Again, in real life, maybe people will be possibly a better example could be like there will be lots of images about sheep, cows, kangaroos, and whatnot, goat and dogs, and can the system automatically identify kangaroos, maybe for an on-farm activity, so that say for example you are sending drones are taking pictures, and can it identify kangaroo presence, something like that. So dataset source could be images, dataset source could be surveys, as I explained before. Dataset source could be wearable devices. These devices these days, like wrist sensors like wristwatch, they can actually collect whole lot of data. Galvano, what they mean like your skin temperature, your sweating level, your body temperature, your heartbeat, your blood pressure, etc. And those data can be used for various purposes. So for example, to assess your mood, to to see like your balance and arousal. So how stressed you are, how frustrated you are, those kind of things can be also done. And data collection can be done through smartphones as well. Just today, this morning, I uploaded a video on my YouTube channel, just a coincidence, on the use of smartphones for data mining. These smartphones these days are 8-core processors and 2 gig RAM, which was quite a dream for even for a powerful laptop few years ago. Data collection can happen through weather stations, on-farm weather stations, etc. Now, I think we can, I'm mindful of the time. So, I mean, it's good to discuss it better rather than rushing it. My purpose tonight will not be to cover all the slides in a rushed way. So in a way that people did not enjoy or did not like anything. Rather, we go slow, but we better discuss things better. Here, this slide is not very important at this stage. All I wanted to say that when you collect a data, like a 2-dimensional table, some of the attributes or features can be numerical. Numerical means numbers, integers, 1, 2, 3, 4. They have natural ordering in it. You can, most of the time, you can apply mathematical operations on them. Some of the variables can be categorical, like Sydney, Melbourne, Brisbane. You cannot apply mathematical operations, or there is no way you can say Sydney minus Melbourne is equal to Brisbane, or Sydney is greater than Brisbane, something like that. Zahid is greater than look, whenever you are saying Sydney is greater than Brisbane, somebody may say, yes, that makes sense, because they are thinking of population, they are thinking of size, those are numerical attributes. But just the word Sydney is not greater or smaller than Brisbane. And dataset can be ordinal. Ordinal attributes are like categorical, but they have a natural ordering, like tiny, small, average. So this is just a brief idea. So yeah, we understand that variables, features, attributes, so synonymous things. So they can be numerical, categorical, etc. Then here is a good. Now we are getting into more interesting topics. So data pre-processing, as I have introduced that in your data lifecycle, you have seen that one of the tasks is data pre-processing, missing value imputation. I will give you an example here. Now you see the first table there on the left, you can see. Let's assume that this is the original data set. This is the pure data set. But let's say while collecting this pure data set, we have collected the table in the bottom, okay, bottom table. We have collected the bottom table where two of the values are highlighted in red font, you can see. So here, for the first participant, hours exercise per week is 95. So we can clearly see that this is impossible. Nobody can exercise 95 hours every week. So something must be wrong there. And actually, when you look at the table on the top, the hours exercise was 5. So there was a mistake. Maybe an additional 9 was entered by a data entry person or whatever. So this is what we call corrupt data. So in a big data set, you cannot manually identify all these corrupt data. So you often need some automatic technique. And here also you can see a question mark. That means the value is missing. The actual value was 8, but in this case, the value is missing. So that's how do you impute that missing value? That's called missing value imputation, corrupt data detection. These are data pre-processing tasks. Other data pre-processing tasks may include discretization, feature scaling, etc. So yeah, let's see an example of missing value imputation. And you may want to install after the lecture, if you like. If you want to play with this, you may want to install Weka. How do you install Weka? Weka is a freely downloadable software. I can see many of you have data science experience already. If you have that, if you have used it before, no problem. If you haven't, it's very simple. All you need to do is just write Weka on your friend Google, and your friend Google will identify the link and you just download this software. It's a freely downloadable software. And if you are still confused or if you are you're struggling, there are lots of YouTube videos, and you can also visit my YouTube channel. And on my YouTube channel, there are a few videos like these red color videos, data mining software, decision tree software. These videos, any video with the software at the end, something like that, missing value free software. So these videos generally also demonstrate or show or discuss how to download Weka and how to install Weka and how to install our algorithms, CSU developed algorithms into Weka. There are quite a few CSU developed algorithms freely downloadable. You can use them. Now let's imagine this is a data set, and let's imagine when you have collected the data set, these two values are missing. So the original values were PhD and 85. So the first record, the first person is has a qualification MS and salary 85, and position is lecturer. Second person is PhD, salary 145, position is professor. So look, this is just an example, and somehow these two values are missing. Now let's do it. Let's do a data mining and see how we can actually impute those values. So this screenshot is showing what I will actually now do with you. So okay, so you can still see my screen, I guess. So here is the Weka. After you download the Weka software, you will see this icon, and you double click on this, and then the Weka GUI Weka GUI will come up. So you can see this, then you can actually open the Explorer, Weka Explorer, and you will see things like this. Then you can, in this one, you can actually open any file. Any file, you can actually load any file in this Weka system. So here is I have created a couple of files for you. Let's say here, there is a file called data.arf. Let's open this file. I'm trying to open this file now on WordPad. Sorry, I'm rushing a little bit because I'm thinking of the time, and I hope we have lots of things to share. But in case if we can't cover them in today's lecture, we have next week's lecture and we will discuss them again.
And Zahid, given it's a free lecture, I'm happy to sort of stay a little bit later.
Oh, I can overrun it. Oh, that's good.
That's okay. Yeah. If people need to go, of course they're welcome to. But you know, get to the key points, and you know, like the recording will be there for those that have to miss it.
Okay. Yep. Okay. I will try to be as precise, as straight, direct as possible. But it's good to know that I will not be shot out after 8:30 immediately. But anyway.
Yeah, I'll kick you out straight away. No,
that's right. That's right, Guy. Thank you very much, Guy, for giving me the extra time. Okay, so here I have created two data sets. Let's say this is the data.arff. ARFF is the format that you need to use for Weka. So Weka requires ARFF format data set. It's nothing but the actual data set with some special information at the top. So the special information is very simple. For example, it says at relation, and I have said job. So that means like is the name of the table is job, or name of the data set is job, something like that. And then at attribute. So now I'm listing the attributes. The first one I called it degree, and the possible values I said, okay, they can be MS or PhD, masters or PhD. And you can see the first value is masters, second value, second attributes, second records first attribute value is PhD, third records first attribute value is PhD. So the values on the first column can be MS or PhD. So that's all this is saying. And then at attribute salary. So that means the second attribute, the first attribute is degree, the second attribute is salary, and that can be a numeric value. So it can be any number. So here you can see 85, 145, 145, 85. So these are the salaries. And the third attribute, I am calling it class. So I'm naming it as a class attribute. You will hear this word a lot in data mining, class attribute. Class attribute means sort of the target attribute. And you can actually define any attribute as class attribute if you like. But generally, it means a special attribute that you want to predict for future. For example, disease diagnosis, or for example, in this case, the position, whether this person, this employee is a lecturer or is a professor. So that sort of disease, or maybe for banks, maybe fraudulent customer versus good customers. For insurance company or for banks, maybe loan defaulter or good customer, something like that. So, special type of attribute that you want to predict for future, or that you want to use to discover knowledge around that, so that kind of thing. So people generally call it class attribute. It's also known as target attributes, labels as well. Records may have labels. So here class attributes, I'm calling it LNP. So this is the data set, but you can see that this is the original data set. But let's assume that when we have collected the data set, we could not collect the original data set. Of course, this original data set I'm using as a ground truth, but let's assume we have collected this data set that has couple of missing values. Okay, so when we have collected the data set, the first employee or the participant or the person did not mention his salary or her salary. So that value is missing, or somehow we did not collect that information. So we have seen the study in this research area has seen that if you want to discover knowledge from a data set that has lots of missing values, so often your knowledge discovery may not be as accurate or as useful as if it did not have those missing values. Say, for example, if you are building a classifier that can predict future, if you build the classifier from a data set that has lots of missing values, the classifier may not be as accurate on future records as if the data set did not have those missing values, right? So missing value imputation can be important for many reasons. You can think of many other scenarios where it is important. Now I'm demonstrating how you can do it using Weka. So after you click on Weka, you will see this Weka GUI. Then you click on Explorer, you will see this Weka Explorer. And here you can actually open files. So these are the files that I have on my computer hard disk. And now I want to open this file called data missing. And all you need to do is just use your I'm going to the folder, use your directory to go to the right folder. This is the one, MOOC lecture week 1 dataset. Yep, I'm there. And data missing. Okay, I'm opening the data. So as soon as I have loaded the data, Weka will display the construction of the data or the distribution of the data. For example, it is telling us that the data has 3 attributes. Okay, the underlying data, I have uploaded this data, and now Weka is telling me that it has 3 attributes: degree, salary, and class. And now it's also displaying what is how many of, so for the attribute degree, what are the possible values? MS and PhD. There are 6 people with MS and 8 people with PhD, and it also shows pictorially here with some bar graph. And we could do the same thing for salary. Salary is a numeric value, so we can see the minimum value for salary, maximum value for salary, mean and standard deviation, and some information. Similarly, we could see class, like how many of those different values are there. Lecturer 6 and professors 9 in this data set. Now, what are we doing? We are trying to impute the missing values, right? So there are 2 values missing here. We want to impute. So if we want to impute missing values, there are already lots of softwares that are in Weka that can actually do it. And you will be very happy to see even our software on this is also there. It's called DMI. So if I take the cursor on it, you can see the details of DMI, and you can see Rahman MG and Islam MZ. So Islam is myself, Zahid Islam. So this is our technique. It is also there. So if we now, okay, if we now choose that technique, so that DMI, so DMI has been chosen for imputation, and then all we need to do, just apply. Once we have applied, then it has actually imputed the data set. DMI, apply, and oh, sorry. Okay, let me have a look. So always it happens when I demonstrate something. So what it's supposed to do now, it should say that save it, save the imputed file. So somehow I'm having some glitch here. Okay, let me try it again.
Yeah, we'll go once more. That's okay.
Yeah.
I really like how the bird sits down once it's finished with.
That's right. That's right. Let us try it again. So why, I don't know why this is not.
Oh, because it's the rules. This is how it happens.
That's
as soon
right.
as you want it to work
That's
properly.
right. Yep, that's right. So let's see. I'm opening this. So sometime I have seen that it may depend on the screen. So I'm opening the same file again. Sorry for this. Bear with me. I will.
Oh, so this is all happening on the other screen now, is it?
Yeah, it's happening on the other screen,
Okay,
because I have
beauty.
seen sometimes the screen may cause a, like,
Yeah, no worries.
the weka sometime, gets a little bit confused.
Yeah, sure.
Okay.
I might use this opportunity to just comment on a couple of things that have been said in the chat. There was some talk about these short courses applying for credit for IT Masters postgraduate courses. It's not the case with this one because it's just a Charles Sturt University only short course to sample their graduate certificate. It's not actually part of the credit system. Also, there's heaps of good questions flowing in. Some of them we won't get to just because we'll run out of time. But anything that we don't have a chat about, we can always talk about in the forum. So it's always a great place to thrash these things out in more detail than we can in a given time.
Yeah. Okay. Okay. So so this is what it should do now. Okay. I'm not sure what's happening because when I have opened this missing value imputation, so all I need to do is just apply, and this bar should keep on working, and then it will just ask me to save the file. So it will impute the file, and then it will just ask me to save the file, and I can, possibly it's coming up somewhere else. I'm not sure if it's hidden somewhere in my other screen, but okay, let me share my window, my screen. So I was just doing it this couple of days ago when I was preparing this slide. So look, this is what it says, that save this file, and I saved this file as data imputed ARFF, and I took the screenshot. I opened that file. So we are at this stage that we are seeing this Weka visualization thing in the background. Then we are imputing. We have selected DMI. We are applying this apply button, and then it will say save it, and I saved it as data imputed.arff, and this is that data imputed.arff. And here you see that missing value was there, MS, and the original value was 85, but now the imputed value is 85.2. And the original value was PhD, and the imputed value is PhD. So for numerical attributes, the values can be slightly different sometimes. That's because the imputation uses some statistical sort of approaches, to find out, to make an educated guess, basically, okay? And DMI is one way of doing it. So there are many different ways of doing it. So DMI is just one of them. It makes an educated guess, and this is a very nice technique. It's very successful. We have used it in many places. And also, yeah, so, and for categorical values, it has predicted the categorical value PhD. So one thing I need to tell you, that you should be, as a data scientist, you should be mindful that these are the techniques like that can automatically detect corrupt values, that can automatically impute missing values, but still we need some sort of, if it is very critical, then we need to be very careful before we make a decision based on the imputed values, because these are algorithms, and that in some particular given instance, it can go go wrong. So we need to be mindful of that. So this is an example of missing value imputation. Sorry, I can spend time on the Weka thingy and why it is not working, but possibly that will waste your time. But this is the next step. This is what it will do. I can show you from the screenshot. Now the next slide, I will show you about the next step of the process. Here the second step was data pre-processing, and missing value imputation was one of those pre-processing approach. The second one will be data analysis, right? So here now I will demonstrate again a data analysis activity, again through Weka. Hopefully it will work. Let's say
I'm sure it will.
it should. Let's see what happens. So now the same way, from the same Weka Explorer option or Explorer window, after you have imputed the missing values, after you have identified corrupt values, etc., you can also discover knowledge. For example, you can build a decision tree from it. So I'm opening a file, say data.arff file that does not have any missing value in it. After imputation, you will not have missing values. Your dataset can have missing values, and you can still build classifiers. So I'm now, instead of previously I was using filter, and now I'm using classifiers. Okay, there is a button called, or tab called classify, and if you click on it, and you can choose classifiers, and see there are so many different classifiers, Bayesian classifiers, rule-based classifiers. I'm trying to display or demonstrate a tree-based classifier, and J48 is a very commonly used decision tree, which is actually Java implementation of Professor Quinlan's C4.5. C4.5 is a very common decision tree algorithm, and we also have quite a few of our algorithms in Weka. For example, SIS4, this is we call it systematic forest as opposed to random forest. Random forest is Professor Liu Bruman's technique, a very, very popular technique. And in SIS4, we will not be building random forest, rather we will be building systematic forest so that we can discover knowledge systematically. That's the background for the name SIS4. And this forest PA is also our technique, CSU developed technique. Now I'm demonstrating J48. So when I have chosen J48, I can just start to build a tree. This time it worked. It builds a tree, and you can actually see the tree here. So the tree, you can visualize it. Let us visualize the tree, and then possibly we can see what is the knowledge that we are discovering. So remember, this was your data set. Open the data set again. This was your data set where lots of values, there were different values for degree and salary, and then the class value, either lecturer or professor. Now what a decision tree does is it discovers the pattern why sometimes people are classified as lecturers, sometimes people are classified as professor. And in this case, it has discovered that if degree is MS, master's, then they are classified as lecturers, and the degree is PhD, they are classified as professors. Look, this is just a toy example. Don't believe this data set, okay? So this is just an example. And this 9 means there are 9 records, and this 6 means there are 6 records. So from this, you are now learning that, I can see, okay, this was the data set. It was very hard to discover knowledge from it, but when a decision tree builds a visualizing easy to visualize logic rules, set of logic rules, tree structure, then it becomes very easy for you to understand, for an end user to understand. Your data set, this one is a simple one. This is a toy data set. But in real life, data sets, imagine, may have thousands and millions of records and hundreds and thousands of variables. So it can be very difficult to discover any knowledge by plain eyes. And you also might have noticed that we did not need any pre-assumed knowledge to discover this this pattern. So we did not ask, show us the relationship between degree and position, or show us the relationship between salary and position. It actually automatically discovers these things from a data set. So this is one example I can show. Maybe and you can also discover alternate patterns. Say, for example, if you want to remove this and just want to focus on salary, then maybe there are ways you can actually do it. I don't know whether that will work here. I can build a forest here. So let's just build a forest and classify and start. We can build multiple trees, and then we can have minimum number of records. So these things we can modify in order to build more forests. So what is a forest? In the next lecture I will discuss. Here it has now built forest. Here you can see degree is MS, then it's lecturer. 6 of them are lecturers and no professors. Degree is PhD, then they are professors. That's the first tree. But the second tree says we could also discover this knowledge through salary, not always through degree. If salary is less than 114, then they are lecturers. But if salary is greater than 114, then they are professors. So there are multiple knowledge, multiple views in a data set, in the same data set. So you can use this. Now, at this stage, I am happy to take some question on this. So is somebody asking questions, Guy? Is there any?
Oh, yes, there's many questions. Okay, let's go for a couple. We'll talk about missing records first. What sort of point would you consider imputation to be unfeasible? Is there
that's a very good question. Yeah, that's a very good question. I mean, look, I mean, data science is not a miracle. So if your data collection has 90% records, 90% values missing, it's very difficult to impute. You cannot actually. Often the understanding is generally in most of the data sets, regardless how careful you are, generally for most of the big data sets, 5% values can go missing for various reasons. And in those cases, generally you can impute them. Now, the imputation also requires good relation in the data set, so good pattern. Say, these imputation techniques are, as I said, not magic, right? So what they do, they generally will be very accurate when the attributes are strongly correlated and when the records are very similar to each other. Now, this DMI technique, actually, in this DMI technique, we realize that for a given data set, you cannot increase attribute correlation and similarity of the records. But what you can do is you can actually identify segments, horizontal segments in the data set, in a data set, where the attributes are strongly correlated. Just give an example. I'm giving an example. If I ask you the correlation between age and height for the overall population in Australia, you may see that there is no such strong correlation. I'm a very old guy, but I can be very, very short, and some young guy can be short as well, and some older people can be taller as well. So there is no such strong correlation. But if I ask you, no, do the correlation, find the correlation between age and height in a high school. And then you will see in a high school, generally there is a strong correlation. So when a population has age less than 19 or 20, maybe there is a strong correlation. But in the whole population of Australia, the correlation may be not as strong. So this is just an example that in some areas of the data set, the attributes can have stronger correlation and the records can have more similar to each other. So we try to identify those areas so that we can make better imputation using an EMI equation that is used for, they call it expectation maximization approach to impute things. But the question is very good. Sorry, I'm going a little bit off track. But the question is, at what point it will be unfeasible? It may go unfeasible very quickly. If your data set has, say, very big number of missing values, then it can be very difficult. Quality of the imputation can go a little bit, rough. If you have a chance to have a quick look at our papers on missing value imputation, those papers are freely available, and you will see that we have actually presented experimental result on a massive combination of possibilities, like percentage of missing values, 1%, 2%, 3%, 10%, 15%, and also are the missing values coming from the same column again and again, or they are coming randomly from any column, and what are the situation in terms of imputation. So we have actually presented some empirical result on that may give you some idea. You can see clearly that with number of missing value increasing, the quality is getting lower. Does it answer the question?
I'm sure it answers many.
Okay.
Aaron has asked, when imputing missing values, can you unconsciously introduce a pre-assumption or bias?
Yeah, I mean, the missing value imputation can be rule-based. Say, for example, I can say male and pregnant is not possible. So if you I can ask my software to scan the data set and identify any record having gender equals male and diagnosis equals pregnant, and detect that as a incorrect value, or if the value is missing, say for example salary greater than say 700K, then the value imputation has to be CEO, something like that. So it can be rule based, and if we do it rule based, then it is possible to actually introduce bias without, like, because my rules are based on my knowledge, and my knowledge can be actually incorrect or can be incomplete. So yes, that is possible. But if you use the missing value imputation through statistical analysis, like what these imputation techniques are actually essentially doing, they are studying the data set, trying to understand the relationship, and then among the attributes, among the records, and then when there is a value missing, it's trying to see for similar type of records, what was the value for this one. I will give you an example. The most naive missing value imputation technique can be thought of the mean imputation. So if this attribute, the whole column average is 95, then any value missing is 95. Something that's a very naive, very old or very primitive sort of approach. That's not accurate. But what I'm trying to say here is that it is based on the data sets statistical properties. The system tries to impute a missing value. So it may not be as bad as having some rules, and the rules are guided by my knowledge. So this one, it's kind of like the approach is let data talk. So from the statistical point of view. But as I said, you are 100% right. Andrew, I think, asked the question. You are 100% right. If the pattern is incorrect and the discovery is incorrect, it depends on the accuracy of the algorithm. It depends on the complexity of the missing value, etc. Many a times the value can be incorrect. So there is no reason to be very confident that the imputed missing value is correct. So it's just an educated guess.
Thank you. I too am mindful of the time and going a little bit over. So perhaps we'll just answer one question more, and then we'll start talking about what's coming up next week, and maybe this might lead into what's coming up in future weeks. Neville asks, what do you think about the crossover of data mining and AI, or machine learning, as someone else was referencing?
That's a very good question again. Okay, I'm very happy to hear these difficult and interesting questions. Look, I mean, if I myself was confused, like, what do you mean by data mining? What do you mean by machine learning? Where is the demarcation line? Look, I will share one quick story. I attended a conference. I met a professor from some universities overseas, and then we had good time. We discussed various things. Conference people are relaxed. We discuss about our research topics, etc. And then after I came back to my office after a couple of days, few days, I received an email from that professor, and he said, Zahid, I thought you mentioned that you are a data miner, but when I look at your profile, you have lots of decision tree algorithms. How come you are a data miner and not a statistician? So look, this is an example of overlapping areas. So when I talk about decision tree, knowledge discovery, I very strongly think this is part of data mining, but he being a statistician, he was thinking that decision trees are actually part of statistics, not data mining. And he was confused. So what I'm saying here is the lines are overlapping, the borders are very fuzzy, because the first decision tree algorithm was published in a statistics journal. So it's very difficult. Now, your question is the similar question, like the difference between machine learning and data mining. Look, different people will answer it differently. My answer to this is data mining generally wants to, okay, let's start with, let me explain. Data mining will generally want to discover knowledge and then understand the data set, and then will want to see why this is happening, why this is not happening, what are the reasons, try to make sense of it, and then use this knowledge for future prediction, for decision making, for strategic decision, etc. Right? So that's generally, that's what we think of data mining is. And in many situations that is important. For example, if I go and tell my CEO tomorrow that we have to shut down these and these and these outlets, otherwise we'll be losing this much money next year, and the CEO asks me why, and I say I don't know why. I just know my system is telling me that we have to shut them down, and I don't know why. So then my CEO, of course, will not be very convinced. But in many situations, we don't need to know why. Say, for example, I have thousands and thousands of images, and I need to identify kangaroos or horses in those images. I don't need to know why this is a horse. As long as this is a horse and my system is identifying this as a horse, maybe that's enough for me in that particular situation. So machine learning is generally focusing on just identification, classification, and future prediction, possibly. It does not possibly worry too much about the why part. So why it is important. It's not, some data mining is very kind of attached with business kind of analytics and decision making, strategy making, whereas machine learning is kind of more attached with yes, no kind of things. And AI is, if you install the machine learning on some vehicle, robot, etc., then possibly, as long as the robot, say for example, you are sending a robot to dig out gold from a mine, and as long as the robot turns right when it needs to turn right, you are okay with that, right? You don't need to know why the robot turned right and then turned left and then step forward to fetch the gold nugget. As long as it has fetched the gold nugget, we are happy. So that could be a difference, but I might be wrong. But that's my explanation of the difference between and you could also ask, what is the difference between data science and data mining? So that sort of thing. Yeah.
Indeed, some people have, and I think a lot of the point of these questions is the answer is quite frequently maybe. You know, and you know, it's a great place, I think, to ask these questions is in the forums for each of the modules. Right. We'll put up all of the questions that have been asked, and you know, there's still 25 questions outstanding, and I've got rid of some already that really would be great to have asked anyway. But we'll call it a night for now. Thank you so much, Sahid. Super interesting. You make me want to go back and do high school maths, just so that I can try and understand this a little bit more clearly. What are we going to have a look at next week?
Sorry, Guy, are you asking me?
Yeah, just
okay. Yeah, next week will be actually, I mean, in this week, we also wanted to discuss a little bit of clustering, what is clustering, and show an example of how you can do clustering in Weka, but we can do it next week very quickly. And next week, we'll be discussing more about ensemble of trees. So we have seen in this week what is a decision tree and how come how it can actually discover some knowledge, but we possibly will discuss that a little bit more, that if there is a data set, how we can apply a decision tree and an ensemble of trees. Ensemble of tree is number of trees. If we also call it forest, decision forest. One tree can discover one pattern, but multiple trees can discover multiple pattern and more knowledge about the data set. So we will be discussing those things in the next lecture.
Look forward to it. Alrighty, thanks so much everyone for coming along. Thank you, Chantel, Leif, Rebecca, and Jason for joining us and helping out tonight. And thank you so much, Zahid, for coming along. I'll leave it to you to say goodnight.
Thanks, Guy. Thanks, Guy, Chantel, Jason, everybody. But particularly thanks to all the participants. Thanks for coming. If you did not come, I would not have this opportunity to give a lecture. Thank you.